At the beginning of my mechanical design career, I was so much fascinated about different type of bearings, and I was trying to memorize all the bearings name with their constructions as well as their application, but I used to forget in very short time. Every time I memorize it and forget again, because as you know, there is a many types of bearing. And it is not possible to memorize all the bearings names with their application. At least for me, it's not possible. And then after so many years of experience, I have realized I'm doing something wrong. Completely wrong. Because even if I memorized all the bearings names with their application, it would not be directly useful. Because first we design our application, and on the basis of application, we choose the suitable bearing. We never choose the bearing first and then design according to the particular bearing application. I hope you got my point. So what I did, I started to understand my design and application more deeply. Like the direction of the load in my design, amount of the load and speed, and on the basis of this requirement, I started to push myself to think that what should be the bearing design for this particular application. Like what should be the rolling element of the bearing according to the amount of load and speed, ball or roller, and what should be the contact angle of the rolling element according to the direction of load in my application, like axial or radial or 30 degree or 45 degree. Also, what should be the design of bearing if my application loading is one directional, and what should be the bearing design if my load in application is unidirectional. And most importantly, what types of misalignment I needed in my bearing arrangement, like axially or angular or self-alignment as per my design, as per my application. And when I write down all the requirements, I automatically reach to a bearing name. So hey there, this is Ayush from Master Mechanical Design, and let's understand the bearing like a bearing design engineer, so that we never have to memorize the bearing name and their application. And this bearing masterclass series is into 3 parts. In this part, we will deeply understand the basic of bearing design, like the components of bearing and their role, bearing internal clearance and the bearing precision grade. And we will cover all the basic radial bearings. And in the second part, we will understand all types of thrust bearing and the angular contact bearings. And in the third part, we will learn self-alignment bearings and the most popular combination of the bearing for the different application. Look, in this video I am going slowly step by step. So whenever you feel the slow pacing, you can change the speed as per your liking. But if you are a beginner, you are not allowed to change the speed. Just kidding. So let's start with very basic. What is the bearing? What is a bearing? By definition, bearing is a mechanical element, or we can say machine element, which constrains and enable the relative motion between two parts while supporting the load with very less friction. So what does it mean? It means the bearings have two main basic functions. One, it supports and constrains the relative motion between two parts, means the bearing keep holding two moving parts together. For example, a bearing constrains the car wheels with the car axle and also support the load and rotary relative motion between wheels and the car axle. Why relative motion? Since the wheel is rotating and axle is stationary, so this is the relative motion. Motion can be linear also, like linear motion between LM block and LM rail. So it's a linear bearing. And the second main function of the bearing is to reduce the friction between two moving parts. And why we need to reduce the friction? Because friction makes part wear and tear, and frictions also generate heat, and as a result we lose the transmission energy. So is that friction totally bad? We can say friction is not our enemy. Friction is very important in many applications. Like without friction, car tire cannot run properly over the road. Car will skid, something like this. But in center of the wheel, we need very less friction to smoothly rotate the wheel over the axle. Means it's all depend on the application, where we need to increase the friction and where we need to decrease the friction. So this was the definition of the bearing, that the bearing constrain and enable the relative motion between two parts while supporting the load at very less friction. And now to understand the different types of bearing as a bearing design engineer, we have to start from completely zero. Like we haven't seen any bearing in our life. It sounds crazy, but let's see what I mean to say. Let's say we have a Mustang GT 1967, but the wheels are without bearings. We have the car but without any bearing. And here I want you to assume, I want you to suppose that we don't know anything about the bearing, like bearings not invented yet. So as a design engineer, what we can do? The simplest thing we can do is we can make a hole in the center of wheel according to the size of the axle. I'm calling this part axle. I don't know it is right or wrong, but you understand my point. And we can simply fit this wheel hole, or we can call it housing, or we can also call it bore. It's actually the same thing, into this axle. But there is so many problem, and the first and main problem is that in very short time wheel housing will wear out, because the material of wheel is alloy aluminum. So first of all, we have to save our wheel because it's costly. So what we can do is, we can place a hollow cylindrical piece between wheel housing and axle, this shaft. Why? Because now obviously instead of wheel, this cylindrical piece will be wear out, and we can replace it from time to time. And how exactly we should fit it into the wheel? We will machine the cylindrical piece inner hole in clearance fit at 7, and the shaft will be in G6 close running fit, and we can make the cylindrical piece outer surface for the press fit into the wheel, or maybe interference fit like K6 or P6, so that this hollow cylindrical piece will be properly fixed in the bearing housing and rotate freely over the axle, over the shaft. And to make the motion even smoother, we can apply some lubricant while our grease in between shaft and this cylindrical piece. And my friend, this cylindrical hollow piece called general bearing or bush bearing, or we can say slide bearing. And there is a variety of general bearing according to the material, like soft material, brass, or there can be hardened material bush also. We can also differentiate the bush bearing or general bearing as per the fitment, like press fit or interference fit. Bush bearing can be oil free also, solid lubrication, external lubrication not needed. Also we can go for flange type or step type bush bearing as per our design requirement. And the main advantage of bush bearing is we can use it in both type of motion, linear motion as well as rotary motion. And the cost is very low because there is no any moving part. It's a simple design. Let's further investigate the bush bearing. Since the contact area between bush and the shaft is very large, as a result, bush bearing cause a high amount of friction, high amount of heat generation. So we cannot run the car at high speed because of the friction. So how we can reduce the friction? The first thing we can do is to reduce the contact area. Less contact area, less friction. And the second thing, the very important thing we can do is to change the sliding motion into rolling motion. For example, this is the sliding motion and this is the rolling motion, and the friction in rolling is very less. So what could be the best shape of the metal which can easily roll with less contact area? One, cylindrical metallic roller, or second, a spherical metallic roller. Cylindrical metallic rollers make line contact, and the spherical metallic roller, like a ball, metallic ball, makes the point contact. So the balls make minimum surface contact. So let's put the metallic balls around the shaft, something like this. But the load is heavy and the contact with the ball is pointed, it's sharp, so it could dent the shaft. So we have to add one more bush, hardened bush, over the shaft also. and we can call this arrangement ball bearing. And these are the balls, and this is the inner race, and this is the outer race. It's very simple. But the problem is, these balls will not stay in the place. Balls can easily come out. So to retain the ball between inner and outer race, we can cut a groove on inner and outer race, something like this. Now the ball will roll in between the groove, and we call it deep groove ball bearing. Yes, my friend, when we say ball bearing, it means all the bearings where we used ball as a rolling element. And when we say deep groove ball bearing, it means this bearing. But we usually say ball bearing, but this is the deep groove ball bearing. And now there is one more problem. And the problem is these balls will collide with each other and make friction at high speed. Also, if the balls will not equally distributed, the load will also not evenly distributed all around the bearings, and it will reduce the bearing life. So keep the bearing equally distributed. We have to use a cage, something like this. And this cage also rotate with the balls. So this cage has to be light in weight. And there are mainly three types of cages. Metallic cage, stamped metallic cage. Metallic cage are lighter in weight and can withstand high temperature. But the metallic cage is not perfect for the high speed. So for the high speed, weld machine cage material like brass or alloy is more suitable. Also can withstand high temperature up to 120 degrees centigrade. But for the super high speed like 20,000 rpm, polymer cages are more suitable like PEC or polyamide 66. Yes, if we are going to select the bearing for high speed application, we also have to select the suitable bearing cage. And now to further reduce the friction, we can apply lubricant like grease. But at high speed lubricant will not stay inside the bearing. It will easily thrown out. So to keep the lubricant inside the bearing, we have to seal the ball mechanism with the cover, integrated cover. Also the seal is important when bearing is exposed to the dusty area. It's also prevent from containment. And there are mainly two types of seal. The first one is completely sealed, contact seal. It's a contact seal where we need to complete resistance from water and liquid. But the problem is, since there is a positive contact, friction will be high and we cannot use for the high speed. So for the high speed, we can either use sealed seal, how to pronunciate it, but you can read it. And in this seal, we get a small amount of gap between seal and inner race. And we use this seal where operating environment is relatively clean and low friction condition. Or for low friction, we can also use low friction seal or non-contact seal for further improvement of speed at low friction. And there is one more important aspect of bearing design, the internal clearance of the bearing. And we can define the bearing clearance as the total distance through which one bearing ring can be moved relative to the other. It's like an amount of play. And the clearance in radial direction called radial internal clearance, and the clearance in axial direction called axial internal clearance. And we need the some amount of clearance because of two main reasons. And the first reason is since we fix the bearing with interference fit over either bearing internal race or the outer race. Due to the interference fit, bearing race will expand. And if there will be no clearance within the bearing, ball will stuck between outer race and inner race. And the second reason is when bearing runs at the high speed, heat generates and as a result thermal expansions happen. So we need some clearance to compensate the thermal expansion. So as a design engineer, for high speed application, we should go for high internal clearance bearing. And ISO have established 5 types of bearing clearance. Normal clearance C3, greater than the normal clearance. and so on. C4 and C5. C5 have the greater clearance, and C1 which is less than the normal clearance, and the C2 which is less than the C1 clearance. And these are the internal clearance of the bearing, the tolerance inside the bearing. But what about the external tolerance, tolerance of our bearing ID or bearing OD, which is necessary to know for the proper bearing mounting, like for the selecting the right fit, tolerance or GD&T of our bearing seat or bearing housing. So there is a standard ISO tolerance classes. Normal tolerance class, this is the minimum tolerance class for any bearing. Then we have P6, which is tighter tolerance than the normal class. And then P5, which is more tighter tolerance class than P6. And after P5, super precision bearings grade starts. And the grades are something like this. We will cover these things in more detail in bearing mounting class. But as for now, what is the mean of this bearing tolerance class? So let's say if we have a bearing of internal diameter 60 mm, so it would be fall between 50 to 80 mm. And if our bearing is normal precision grade, we will get the tolerance of our ID is 0 to minus 15 micron. And for the same ID, in P6 class, ID tolerance is 0 to minus 12 micron. And the same ID in P5 class, 0 to minus 9 micron. And if your bearing is super precision, you can get 0 to minus 5 micron. So what is the main purpose or main advantage of using high tolerance class bearings? So the first advantage is the dimensional accuracy. And the dimensional accuracy is not only about the tolerance accuracy in ID, OD or width. High dimensional accurate bearing also gives us geometrical accuracy, like the position accuracy of the inner race with respect to the outer race. Also the high grade surface finish and well dynamic balanced, which allow the bearings to achieve the high speed, super speeds like 50,000 RPM. Could you imagine? And these all things applies to almost all types of rolling element bearings. And there are even more depth concept of the bearing design that as a design engineer we should definitely know. So we will definitely discuss all those things in different videos. And again, let's back to the basic. Here the deep groove ball bearing have the point contact, and to be exact, it's actually not a sharp point contact. In operating conditions, balls make tiny circular contact because tiny deformation of the ball under loading condition. But the fact is the ball bearings can provide high speed among all types of rolling bearing because the balls makes the smallest contact and produce the lowest amount of heat at high speed. So the thermal limitation of the ball's bearing is the high. But as the contact area of the balls is very less, balls will apply the high amount of stress on the contact point with inner race and the outer race, because we know that the stress is equal to force divided by the area. So less area, more stress at the heavy load. So how we can increase the loading capacity of the ball bearing, deep groove ball bearing, for the same size of the shaft, for the same size of the ID, internal diameter? So the first thing we can do is we can increase the size of balls, diameter of the balls. For example, the bearing 6002, the bearing ID is 15 mm and the OD is 32 mm. And for the 6202, the bearing ID is still 15 mm, but the OD is 35 mm. And for 6302, the ID is same 15 mm, but the OD is 42 mm because the ball size is increasing. But what if we don't have the much radial space in the bearing housing? So the second thing we can do, we can use the multiples bearing in a row. But this is only possible if there is enough space in axial direction. So the third thing we can do is we can use double deep groove ball bearing if the space is limited. But still we can increase the capacity up to a limit because it's a ball contact, a small contact. So for the heavy load we can use roller bearing, cylindrical roller bearing. and the cylindrical roller bearing can withstand highest radial load among all types of bearing for the same ID, for the same internal diameter, because the cylindrical roller bearings provide complete line contact. And whenever compare the two bearings, always choose same ID of the bearing. But with cylindrical roller bearing, we cannot achieve the high speed like a ball bearing, because the contact area is high. It's a line contact, means high amount of heat generation. And there are mainly two options in cylindrical roller bearing. One is the with cage, and the second full complement cylindrical roller bearing, means without cage, means more number of rollers, maximum numbers of rollers. And the cylindrical roller bearings also comes in double row. And if space is very less, we can decrease the diameter of the roller, and it's called needle, and we will call it needle bearing. And we use the needle bearing only if the space is limited. And these all three types of bearings are the basic radial bearing, and none of these bearings are used in the car wheel. So in the next part, let's see exactly which bearing we use in the car wheels. But we will come to this bearing step by step. So the next video should be on your screen, or please check the description. Thank you so much for the watching.